G'day legends, welcome to our channel. Today we're going on a journey through space to discover 25 space facts that will totally freak you out and blow you away. We're talking about things that are so massive, powerful, and weird, they'll make your hair stand on end. Buckle up, because this is going to be a wild ride through the universe. Get ready to have your mind blown wide open. Picture this, the universe is always getting bigger, expanding every second. And get this, the further away galaxies are, the faster they're shooting away from us. So, what does that mean for us Earthlings? It means the universe is going to get colder and darker in the future. The light from galaxies will get dimmer and dimmer until all that's left is darkness. But don't worry, we've got billions, maybe even trillions of years before that happens. Black holes. Just hearing the name is enough to send shivers down your spine, right? And for good reason. These are like giant vacuum cleaners in space, sucking up anything that gets too close. Imagine a place where gravity is so strong, so intense, that not even light can escape. These monsters are born when massive stars collapse in on themselves, creating something called a singularity. And if you thought that was scary, get this. Black holes can actually warp time and space itself. If black holes are the heavyweights of the universe, then neutron stars are the featherweight champions. But don't let their size fool you. These little guys pack a serious punch. Imagine squeezing the entire sun into a ball the size of a city. Just a teaspoonful of this stuff would weigh billions of tons. Chapter 4. Rogue Planets, the Cosmic Nomads. We all know that planets orbit stars, right? Well, not all of them. Rogue planets are like cosmic wanderers, drifting through space without a star to call home. They were probably kicked out of their star systems by the pull of gravity from other planets. Some scientists reckon that rogue planets could even have life on them, with oceans deep underground heated by the planet's core. Chapter 5. The Great Attractor, a Cosmic Mystery. Hidden behind all the dust and gas in the Milky Way, there's something massive pulling our entire galaxy towards it. We call it the Great Attractor. This thing is so dense that it warps the fabric of space-time, dragging everything near it towards itself. Chapter 6. Gamma-ray bursts. The universe's biggest bangs. If you thought supernovae were massive explosions, wait till you hear about gamma-ray bursts. These are the biggest explosions in the universe, releasing more energy in a few seconds than our sun will in its entire lifetime. They happen when massive stars collapse or when neutron stars crash into each other. They're a powerful reminder of just how much energy is out there in the universe. Chapter 7. Dark Matter, the universe's invisible hand. Most of the universe is made up of something we can't even see or understand. We call it dark matter. It's like a ghost in the universe. We can see its effects, but we can't see the stuff itself. Chapter 8. Dark Energy, the universe's accelerator. If dark matter is the universe's invisible hand, then dark energy is its foot on the gas pedal. This mysterious force is making the universe expand faster and faster, pushing galaxies apart at an increasing speed. Dark energy is a reminder that the universe is full of surprises. Chapter 9. The FMY Paradox. Where is everyone? The universe is massive, ancient, and full of stars and planets. So, with all those places where life could exist, where is everybody? This is the FMY Paradox. The chances of us being alone in the universe are super slim, but we haven't found any solid proof of aliens yet. It's a question that has puzzled astronomers for ages. Chapter 10. The Cold Spot. A Cosmic Conundrum. Imagine a huge, empty part of space that's colder than everything around it. This is the cold spot, a weird spot in the cosmic microwave background radiation, which is like the afterglow of the Big Bang. Some theories say it could be a sign of a parallel universe, like a bruise from when the multiverse was created. Chapter 11. The Heat Death of the Universe. A long, cold goodbye. Everything has to end eventually, even the universe. One theory is the heat death. No more stars, no more galaxies, just a cold, dark, empty void. Chapter 12. The Big Rip. The universe's grand finale. If the heat death is like a slow fade to black, the Big Rip is like the universe going out with a bang. Imagine dark energy, the thing that's making the universe expand, getting stronger and stronger over time, until it eventually rips apart the fabric of space-time itself. It's a scary thought, but luckily, it's just a theory for now. Chapter 13. The Multiverse. Infinite Realities. What if our universe isn't the only one? What if there are countless other universes out there, each with its own laws of physics and its own story? This is the mind-blowing idea of the multiverse. Imagine a never-ending sea of bubbles, each one a different universe, all existing at the same time. We haven't found any proof of it yet, but it's a pretty exciting possibility. Chapter 14. The Oort Cloud. The solar system's icy halo. Way out beyond Pluto, even further than the Kuiper Belt, there's a massive spherical cloud of icy objects left over from when our solar system was formed. This is the Oort Cloud, home to trillions of icy objects, some as big as mountains, others as small as pebbles. We've never actually seen them directly, though. Chapter 15. The Kuiper Belt, a cosmic shooting gallery. Past Neptune, there's a region of space full of icy objects, leftovers from when the solar system was young. This is the Kuiper Belt, a cosmic shooting gallery of dwarf planets, asteroids, and comets. Pluto, which used to be called the 9th planet, is one of the biggest things in the Kuiper Belt. Chapter 16. The Hubble Deep Field, a window to the early universe. Imagine pointing the Hubble Space Telescope at what seems like an empty patch of sky. What would you see? When astronomers did that, they got an amazing surprise. The Hubble Deep Field. This image showed thousands of galaxies, some of the faintest and most distant objects we've ever seen. Chapter 17. The Cosmic Microwave Background, the afterglow of creation. Imagine looking back in time all the way to the beginning of the universe, to just after the Big Bang. This is the cosmic microwave background, a faint, even glow of microwaves. By studying it, we can learn about what the early universe was made of, how hot it was, and how it changed over time. Title: The Age of the Universe, a Cosmic Clock. How do we know how old the universe is? It's kind of like counting the rings on a tree, but instead of trees we use stars. By looking at the oldest stars, we can figure out roughly how old the universe is. And it turns out the universe is about 13.8 billion years old. The universe is big, like really, really big. The part of the universe we can see, called the observable universe, is about 93 billion light-years across. The light from the furthest galaxies has taken over 13 billion years to reach us. It's pretty mind-blowing when you think about it. We've been talking about the observable universe, but what about all the stuff we can't see? The observable universe is just the tip of the iceberg. It's the part of the universe that's close enough for its light to have reached us since the Big Bang. But there's a whole lot more universe out there beyond what we can see. We don't know how big the universe really is, but it could be infinitely big, going on forever. It's crazy to think there might be whole galaxies and alien civilizations out there that we'll never even know about. Light travels incredibly fast. It's the fastest thing in the universe, clocking in at a whopping 299,792,458 meters per second. But even at that speed, it still takes time for light to travel across the vast distances in space. When we look at distant galaxies, we're actually seeing them as they were billions of years ago. Our galaxy, the Milky Way, is on a collision course with another galaxy called Andromeda. But don't worry. This cosmic crash won't happen for another 4 billion years. When these two giant galaxies finally collide, it will be a slow and graceful dance. Stars will be flung out into space, brand new stars will be born, and the two galaxies will eventually merge into one giant elliptical galaxy. Chapter 23. The Drake Equation. Searching for ET. How many intelligent civilizations are out there in the Milky Way galaxy? That's a question that has puzzled astronomers for ages. Back in 1961, a bloke named Frank Drake came up with an equation to try and estimate the number of detectable alien civilizations. It's more of a thought experiment than an exact calculation, but it highlights the important factors for intelligent life to develop. Chapter 24. The Goldilocks Zone, the habitable zone. Not too hot, not too cold, but just right. That's the Goldilocks Zone, the area around a star where conditions are perfect for liquid water to exist. Things like the planet's atmosphere, its magnetic field, and its geological activity all play a part in making a planet suitable for life. Chapter 25. The Pale Blue Dot, our cosmic address. Back in 1990, as the Voyager 1 spacecraft was leaving our solar system, it turned its camera back towards Earth and snapped a picture. From Voyager's perspective, over 4 billion miles away, Earth looked like a tiny pale blue dot caught in a beam of sunlight. This famous image, known as the pale blue dot, reminds us just how small and fragile our planet is and how precious life is. In the grand scheme of things, we're just a tiny speck of dust in a vast and indifferent universe. Outro. Thanks for exploring the cosmos. Thanks for watching, everyone. If you enjoyed the ride, hit that like button, subscribe to our channel, and ding the bell icon for more awesome content. The universe is a massive and mysterious place full of wonder and endless possibilities. It never ceases to amaze and inspire us, and we've only just scratched the surface. Let us know in the comments which space fact you found the most mind-blowing. Keep looking up, keep asking questions, and never stop exploring.